Welcome guys to keep solving our subject physics GRE. So 84. Basically this kind of question, then I suggest that you do not write the Lagrangian and keep trying to solve it because it's very difficult. But you can remember the phase, basically the phase of this one, the phase of this, the common knowledge of these normal modes. And he asked about what is the highest normal mode. Okay, so the highest normal modes usually is basically two masses out of phase. Okay, and the smallest, lowest means that in phase. So the first one is smallest. Smallest, basically there's there's effectively no k. So basically this is a square root of g of l. And when it's out of phase, basically you just similar as the original g over l, but plus each term k. So this you remember if you have a single spring and there's a mass, then the frequency is k over m. So just k over m1 plus k over m2, which is out of phase. So out of phase, just add all of the frequency together. So the answer is D. And basically B and C are impossible, right? Because you know that the answer must corresponding to some G. So the remaining is D or E, and the A is immediately can be cancelled because A is the lowest normal mode. So you can guess the answer must be D or E. Oh, well, okay. So 85. So basically you have a small amplitude, and you ask about what determine this the wavelengths, and then you say that you might want to consider limit case. Okay, so somebody already give you a hint. So if m is infinity, then that means this is fixed. So this point is fixed because m is so large. So basically your answer should be, your L should be basically lambda, or the multiple of lambda. Okay, so L can be n lambda, where n is an integer. Okay, so when mu over n is 0, then this is the A say the cotangent 2 pi L divided by lambda should be 0. That means tangent 2 pi. That means tangent 2 pi L divided by lambda should be infinity. So the A choice tell you that, which is that 2 pi L divided by lambda can be pi over 2, which L is what? L is lambda over 4. So A is not correct. Okay, and then when mu go when this is 0, then tangent is 2 pi L divided by lambda. So this tangent must be 0 or pi. Tangent must be 0 or pi. Okay, so the second one B can be correct, and C also can be correct because the tangent, the 0 for the tangent is the same as the tangent for sine. And the DE can be correct. E is not sure. E is not correct. So we at least have BCD. Okay, so this is the first choice. And when mu is m is 0, so this can be open. So open, right? You can open, right? So open. If you open, then you can have very large wavelength. So basically your first answer should be lambda equals to 4L. So lambda is LL. So lambda can be 4L. So which one has this one and has this answer? The answer is B, right? Because when this is infinity, then tangent can take pi over 2. Then you will get this one. So the answer is B. B is the only answer. Okay, so 86 is also a easy question. When somebody tell you that you have your in XY plane, basically you have a positive magnetic field and positive y direction electric field. Okay, so basically this is the electric field of what you have. Okay, and so you see there's so the Lorentz force is QE plus V equals B. So you know that there's a positive E at y direction. So this particle should move along y directions, keep going. So which one has keep going? A or E? A or E? But there's a magnetic field, right? So it should have some other trajectory. So the only remaining is E. The only remaining is E. Okay, so 87 too small pin. Basically 87 you can read the question by yourself because which is somewhat long. But all we need to is just find the angular momentum. Angular momentum. Okay. So basically we have the Faraday's law. This is Faraday's law. So basically if for Faraday's law we take E equals to 2 pi d divided by 2 because E is here, right? This is 2 pi d divided by 2 is equals to the flux. So beta square beta change with time the magnetic field change with time times pi r square. Magnetic change of time times pi r square, and then we have E is just the magnetic field change of time r squared divided by d. And then we have force basically is QE. So this is the force. So what we have is the torque just R cross F. So we can compute, we get the Q B dot R squared, right? We just times D, and then there we just times D. Okay, so the answer is A. Answer is A. And the D said it does not rotate because of violate conservation, but there's a torque. So if there's a torque present, then there's no so-called angular momentum conservation. There is no so-called angular momentum consideration. Okay, so for the 88, the coaxial cable has a cross section. Okay, so I think for this one you can use Ampere law to solve it, but I think it's enough to guess the answer. So basically you have this coaxial cable and there's I in and I out. Okay, so if R is larger than R is larger than C, then your total enclosed current is 0. So that means when you're larger than C, your magnetic field must be 0. So A is not okay, B is okay, C is not okay, D is okay. So answer must be D or B or D. And E is definitely not correct because because you know that it must depend on R. Okay. So the first so also we can compute the magnetic field in this region. So basically we get the B equals to B times 2 pi R equals to mu naught I d pi I 2 pi R square pi R square times pi R square. So we know that the B is proportional to R, so B is linear. So A is the only answer. From 0 to A, which is linear, B is the only answer. B is the only answer. I think it's enough for today, and I will see you guys in the next video.